Hey students, it's me, Mr. Fitz. So I just want to take a few minutes to talk about symmetry. So what is a symmetry? Symmetry is a specific type of transformation where an object is mapping onto itself. So what does that mean? That means the object is actually moving in the coordinate plane somewhere. So it's kind of moving around, but all of the points are mapping onto other points. So it looks as if the shape hasn't moved. So, for example, this would be an object that has reflectional symmetry, meaning if we flip this over what looks like the y-axis, it's going right on top of itself. So, and then here's an example of rotational symmetry. So this object, whatever this function is, if you rotate it, you spin it 180 degrees, it's exactly on top of where it was before. So the object is moving, but it appears like it hasn't. So let's go over a couple of the problems. Um, let's take a look. So here we go. So for example, let's look at, say, this first problem here. Number one, which transformation will not carry the square below onto itself? So this is a multiple choice question. So think about this, like this is going to be a reflectional symmetry. So you think about what are the lines of reflection of a square? The lines of symmetry, I should say. So any regular polygon, and a regular polygon is a polygon. So these are polygons back here. A regular polygon is a polygon that has all equal sides. And then, so if it's a regular polygon, it has the same number of lines of reflection as sides. So a square, for example, would have four lines of symmetry that map it onto itself. So these four lines. So what are these lines? So we have, I'm just going to list them out. So this first one here, and use that color. This is the line y equals 3. Um, y. And then this line here, use a different color, green, is the line y equals x plus 5, right? Because the y-intercept is 5. And then we have, say, this one here. This would be the line y equals negative x because it has a slope of -1. And what's the y-intercept there? +1. And then lastly, we have this line here, which is the line x equals -2. Okay, so those are those four equations. And what do we think about? Uh, which transformation will not carry it onto itself? So those are the lines of symmetry. So we can kind of like compare to the answer choices. So a reflection over the line y equals -3. Well, that's not going to work. That's this line here. So that's the line y equals -3. So it's not that one. A reflection over the line x equals -2. This one does work. A reflection over the line y equals 3. That one does work. And then a rotation counterclockwise about the point -2, 3, 90 degrees. That's the center right here, right? This is -2. Sorry, -2, 3. That's the center point right here. So if you rotate it, yeah, 90 degrees about that center point, it'll be onto itself. So all of these work. So they're wrong because they're right. And yeah, so that's that one. I'm not going to go over too many more of these just because I want to like save time. So if you have questions about these, just be careful because like this one here is which one doesn't work. And then like this one is the one, which one carries the transformation onto itself. So this one, you have to look for the one that does work. So just be careful with that. Okay, so we'll go over some of these in class too. Let's look at some of these. I wanted to talk about regular polygons. So a regular polygon is rotated about its center. What is the minimum angle of rotation that would carry the figure onto itself? So again, any regular polygon is going to have the same number of lines of symmetry as it does sides. So for example, this one would have 5 lines of symmetry. That one wasn't correct. Let me undo that one. Sorry. So that would go there. And this one would go here. And this one would go here. So this is basically the center right here. So it has 5 lines of reflection, but also it has rotational symmetry. So let's think about this. And what do I mean by rotational symmetry? So we'll go ahead and erase these. So if we think about just putting a circle around this thing, so that's what I'm going to do. Let's put a circle. Something like this. So if we put a circle around it, and then think about a circle has 360 degrees, right? So if we think about how many degrees would there be in each of these slices of the pizza? So if we think about like slicing this into say 5 pizza slices, so the whole circle, right, has 360 degrees. So each one of these is going to be 360 divided by 5, which is 72 degrees. So each one of these is 72 degrees. So the minimum angle rotation that would work is 72. Now, what could also work if it doesn't have that word minimum is any multiple of 72, right? So if I turn this shape every 72 degrees, it's going to be mapped onto itself. So you could do 72, 144, 216, which is 72 times 3. 72 times 4 is what that's 200 and 7 times 4 is 280 plus another, 288 and 360. So any of those would work. So just wanted to show you that one. And then this one here is very, very similar. What's a minimum angle of rotation that would carry this figure onto itself? So I think it's got 6 sides. Which angle of rotation would carry a regular decagon onto itself? So a decagon is this shape right here, has 10 sides. So if you think about a 10-sided figure, and you have to rotate it every 360 divided by 10 would be 36 degrees, right? So that would be the decagon. Lastly, this question here is a certain regular polygon is rotated 120 degrees about its center. Which carries the figure onto itself? Which regular polygon could this be? So think about this is like the same problem in reverse. So what figure would you have to rotate 120 degrees about its center that would carry the figure onto itself? So what has a degree of rotation of 120 degrees? So let's do each one of these. So decagon would be 360 divided by 10 is 36. Pentagon is 360 divided by 5, which is 72 degrees. Hexagon, 360 divided by 6, because that has 6 sides, is 60 degrees. And a square is 360 divided by 4, which is 90 degrees. Well, it doesn't seem like any of those work, right? Aha, but this is like back to what we were talking about here. If we think about the hexagon, which is actually this shape up here, let me show you. So the hexagon, if I spin it every 60 degrees, whoop, so if I spin this 60 degrees, it's going to be onto itself, but also 120 degrees, 180 degrees, 240 degrees, 300 degrees, and then 360 degrees. So if I keep spinning this thing this way, it's going to continue to be onto itself. Okay. So hopefully that helps. Please let me know if you have any questions, and thank you for watching.